Welcome to Pattern Discovery Technologies' general walkthrough of CompressionInsight. CompressionInsight is a tool that Pattern Discovery has created to help relieve the burden of understanding what the exception and compression values should be for a typical PI server. Before we get too deep into the walkthrough, let's understand here what information we're going to see on the screen. So on the far right here we have a view of the details of the analytics jobs that are currently executing on the analytics server that's running in the background here. This will tell us which jobs are currently scheduled to run, which jobs are actually running, and when they should run. We're not really that interested in it for the time being, but it is available to inspect. The middle screen here is our document view, and that's where we'll see this summary plus any detailed windows that we might bring up for each individual tag. The leftmost pane here, it shows us a summary of the tags that we've included in CompressionInsight. We can see that these tags here, I've added some prior to the recording this video, and these tags have entered into the ready state. And so what we do is we understand what the scan rate is of each tag, and we make a forecast of when we would have seen enough data to make a valid recommendation. And so, for 1 second scan rate tags, that's about 24 hours worth of data. So we can see here that my PI tags and my recommendations for those tags have entered into the ready state, as shown here. Okay, and so this is our navigation pane. Our summary view here, right in the middle, it's fairly noisy, and so I'm going to actually show off some of the options in the tool. And I'm going to clean up the summary view a little bit. I'm not really that interested in seeing all of the columns of information that are available to see. And so I'm going to turn some of those off. That cleans up the user interface quite a bit. So what we're left with now is a bunch of information that's color-coded. Now let's not get confused too much by the color coding. We'll turn that off for now. And so now we see a run-through of all the tags that we have recommendations for, and certain characteristics for those recommendations. Now we can filter down what we see in this view using the filtering options down here on the bottom. We categorize each recommendation that we make based on a confidence level. Okay, and for this walkthrough, we're going to assume that we're only interested in high confidence recommendations. Okay, so now if we color code those, we can see again that they're all going to turn red because they're all high confidence. This grid is fully sortable, and so we can sort by, say, fidelity change, which is a measurement of the improvement of the fidelity that our recommendation is going to make over your current settings. So if we review now each of the columns that we're looking at, the first column that we're looking at here is snapshot count, and we can see that I have about 136,000 snapshot values that we're going to run our analytics against. Given those 136,000 snapshot values and your current exception and compression settings, you are currently retaining about 43% information in your archive. Okay, we'll see what that means in a little bit. Our recommendation will improve that retention to about 77%. Okay, and then it shows counts. If we look at a detailed view here, we'll have a better understanding of what these columns mean. So looking at a detailed view, we can see that this is a fairly typical archive. If we went and hit a PI server and brought back a trend of the information that's stored in the archive. Now we've learned in talking with customers that the engineers are fairly concerned when they see straight flat lines on their trends, because they have an understanding that there's probably detail that's hidden behind the archive that's actually not being stored properly. And if we turn on the snapshot values, we can see pretty clearly here that there is quite a bit of detail that's being compressed away by the current settings. Now we've done analysis against the 137,000 snapshot values, and we've automatically come up with different compression and exception recommendations here that are very different from the current values that we can see. And our recommendation for compression and exception will improve the information retention from 44% roughly to about 77%. And if we look at what that looks like on a chart, we can see that our recommendation is going to chart a little closer to the snapshot signal than does the archive. Now we know that when you improve data fidelity, there's a high likelihood that you're going to also increase the amount of data that you need to store to represent that fidelity improvement. And so if we look at the information shown above here, we can see the current settings are going to yield about 44% information retention, and then we're going to store about 0.5% of the original data. Our recommendation here, on the other hand, is going to yield about 77% information retention, and we've more than doubled the amount of data stored, up to about 1.2%. If you want to look in absolute values, then of the 137,000 snapshot values that we're storing, current settings would store about 650 of those. Our recommendation would store 1,600 snapshot values in the archive. And so this gives us a chance to both visually understand the impact of our automatic recommendation, as well as understand the metrics behind what this change would actually mean. We can jump back to our summary view here and look at another tag. I'll do the same kind of reveal that we just looked at. Again, a fairly typical trend line. Snapshots are moving around quite a bit, and then again, our recommendation for this signal is tracing the original snapshot values a little better. And we can see some similar metrics here. Okay, based on our recommendation, we're going to store more than twice the amount of data, but we're going to improve information retention from 49 or almost 50% up to almost 76%. Okay, that's fine and dandy, but it's very possible that engineers are going to look at this and say, you know what, I need better fidelity even still. I need maybe to improve this fidelity from currently 50%, let's say up to about 95%. And then we want to evaluate that impact. Well, we have what we call a manual mode here, where we can convert that tag over. And then when we have a look at this, the tag in manual mode, we see some new user interface controls here that we can play around with. So you can specify the deviations yourself, and you can mess around with the numbers here, the exception and the compression deviation, and evaluate the change it's going to make against the signal. Or you can simply specify that you want 95% fidelity, hit our refresh button here, and the server then is going to recalculate what it's going to take actually in terms of data storage to get 95% data fidelity. So we're going to go from 0.6% of our total data stored up to 10.6%. So there's a hefty increase here, but we're increasing our data fidelity substantially. Okay, a picture's always worth 1,000 words, and so if we look at our snapshot values, here's what our snapshot will look like. There's the archive. Okay, and so we've seen this story before and understand it. If we look at our recommendation, it does a little better job. Okay, so we're pretty happy with that, and we can improve it to that using our automatic recommendation. But our custom recommendation, using yielding 95% information retention, traces the snapshot very well. And we expect that to be true because we're getting 95% information retention, so we can reproduce 95% of the original signal. Here's an area here where that custom 95% information retention isn't reproducing 100% of the signal, but that's very on a very detailed level. Again, if we drill in, we can see the same kind of effect. Our archive, by the way, would go nowhere near the kind of resolution that we're seeing with the custom value. Okay, so it's very possible that your engineers, when they're evaluating the kind of compression that you're seeing against the current settings on your PI system, they may just decide, what, we should probably just see 95% information retention across all tags. And if you want to do that, then you can simply select all your tags and then hit a 95% target fidelity, click this button, convert them all over, and then you'll start getting recommendations that will guarantee you 95% information retention. in your archive, at least given the data that we have access to today. I'm not going to do that, but I just wanted to show that option. Now, once we have recommendations that we're happy with, the next step, clearly is either to update those settings on the Pi server or create a report that we can distribute to all the interested stakeholders for review. If we want to update the Pi points, we can do so on a one-by-one basis, where we can update just this Pi point here, just this FIQ50, or we can update all the Pi tags that are shown in the current view here in a shotgun approach. And we have two kinds of reporting. So we have a simple PDF report that basically is an information dump of the grid that we can see in front of us here, or we have a CSV report. And that CSV report has the same look and feel and format that's used by the OSIsoft Excel SMT plugin. And that'll allow you to review those exception and compression settings, as well as, in a shotgun fashion, upload those all to the Pi server at a later time. That's all we have for the general walkthrough for CompressionInsight. Please have a look at the YouTube channel for some more specific examples of features. Thanks very much for watching.